Today we are going to solve some of the questions which will help you to solve in graded assignment. So here we have some of the definitions. The first one is random experiment. What is a random experiment? Just a second. So what is a random experiment? A random experiment is an experiment whose outcome is not predictable with certainty, right? Like if we are tossing a coin, we know the outcomes. What are the outcomes? The outcomes may be head or maybe tail. So it is, the outcome is predictable, but we are not predicting with certainty that yes, we are sure that only head will come or only tail will come. So a random experiment is an experiment whose outcome is not predictable with certainty. Okay. A sample space is a collection of all possible outcomes, right? So if we are tossing a coin, so what are the possible outcomes? It can be head or it can be tail. These are the possible outcomes. Or if we are rolling a die, then what are the what are the possible outcomes? It can be 1, 2, 3, 4, 5 and 6. So it is a sample space. Now event, outcomes or combination of outcome are termed as events. That is, an event is a subset of the sample space, right? So if I have a sample space, this one, okay, I'm taking this one. So what is an event? So I'm just taking A as an event, that is the when I roll a die, I get an even number. So what is an event? A is an getting even number, correct? So this is an event and it can be equal to 2, 4 and 6. So if you look into the this is the sample space, okay, this is the sample space and this is A event. So 2, 4, 6, it is a subset of the sample space. From this sample space we are taking out one sample, okay. Now subset, for any two events A and B, if all the outcomes in A are also in B, then we say that A is a subset of B. So if we look at this, A we have 2, 4 and 6, right? And sample space is this. So we see that A is a subset of S because all the outcomes of A are also in S, right? So we say that A is a subset of S, okay? Now, question 1. Consider the following experiments. Selecting a family out of a given group of families, selecting a card from a pack of playing cards, and rolling a die and noting down the number on the upper face of the die. Which of the following is a random experiment? So, what is a random experiment? Whose outcome is not predictable with certainty, right? So, first option is selecting a family out of a given group of families. We have four groups of families, right? And from that four groups we have to select a family, right? So we the outcome, we are not with certainty, we are not uh, predicting the outcome, right? Which group of family will be selected, we are not, like, we don't know with certainty which group is going to be selected, right? So it is a random experiment. Then second, selecting a card from a pack of playing cards. So in total we have 52 cards, right? And from these 52 cards we can have any one of the cards, right? So we are not certain which card would be selected. So it is also a random experiment. Then rolling a die and noting down the number on the upper face of the die. So for in a die we have 5 and 6. These are the numbers, right? So we are not with certain that which number will come on the upper face of the die. So C is also a random experiment. So option 4 is the correct option, that is all of the above experiments are the random experiment. So if we look into the solution from the definition of random experiment, all the given are random experiments. So all of the above is the correct answer, okay. Now question 2. After throwing off 2 dice, here we are throwing out 2 dice, Ramesh gave the following statements. There are 5 ways of getting the sum of numbers as 5. The experiment is not a random experiment and getting the sum of 12 is an event. So which of the following statement is true? So if we look into the first statement, right? The first statement is there are 5 ways of getting the sum of number as 5. So what are the what are the samples or what are the combinations of getting sum as 5, right? So first of all we can have 3 comma 2, we can have 4 comma 1, we can have 1 comma 4, we can have 2 comma 3. So these are the 4 ways by which we can get the sum of numbers as 5. But here it is writing there are 5 ways. So this option is wrong. Now, next, the experiment is not a random experiment. It is a random experiment, right? So because we are throwing two dice, okay, and we are not certain like what the numbers will come, right? So we are not certain, we don't know the outcome, right? So option 2 is also wrong. This is a random experiment. And third, getting the sum of 12 is an event, right? Getting the sum of a 12 is an event, a bigger like on the basis of the event statement, right? So option C is the correct statement. Okay. So if you look into the solution, the number of ways to get 5 as sum of numbers are this. That is, there are 4 ways. So statement 1 is incorrect. Statement 2 is incorrect because it is a random experiment. And from the definition of random experiment and events, it is clear that statement 3 is correct. Okay. Now, two unbiased dice are thrown. Find the probability that both the dice show the same number. Okay, we have to calculate that both the dice should have the same number. Like we can have 1 1, we should have 2 2, 3 3, 4 4, 5 5, and 6 6. So how many numbers are there? There are 6 out of 36, right? So the probability would be 6 out of 36, that is 1 by 6. So let us see the answer. The total number of possibilities, that is the number of outcomes in sample space, are 36. The favorable cases that both the dice shows the same number are 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. Thus, the probability that both the dice show the same number will be, favorable outcome is 6 and total number of outcome is 36, which will be equal to 0.17. Okay. Now, same situation, we have our second part. The first die shows 6. That is, the outcomes can be 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5, and 6 comma 6. What do you mean by this? That the first die, when we throw, it gives 6 as a number, and at the second time we throw, it gives 1 as a number. Similarly, for the first die it gives 6, and for the second die it gives 2. So these are the outcomes that we get, right? So we have to find out the probability that the first die shows 6. So here we have the cases here. So how many cases are there? 1, 2, 3, 4, 5, and 6. And how many total cases are there? 36. So probability is favorable outcomes, that is 6 upon total number, which will be same as 0.17. Let's look into the solution. Here we have the total number of possibilities, that the number of outcomes in a sample space is 36, and favorable cases are, these are the cases. So probability will be the favorable cases divided by the total number of cases, which is 0.17 as the answer. Okay. Now question 3. We have the same case only. The question is, the total of the numbers on the die is greater than 8, right? That is the total, that is the sum of the numbers should be greater than 8. It can be 9, it can be 10, it can be 11, and it can be 12. So we have to look for the cases in which the sum is 9, 10, 11, and 12. Okay, so let's look into the solution. So the total number of possibilities is 36. The cases favorable to getting a total of more than 8 will be 3 6, which is 9, 6 3, 9, 4 5, 9, 5 4, 9. Okay, then 4 6 10, 6 4 10, 5 5 10, 5 6 11, 6 5 11, 6 6 12, right? So these are the sum which are greater than 8. So how many cases are there? 1 2 3 4 5 6 7 8 9 10. So total number of favorable cases are 10 divided by the total number of cases, which is 36. So 10 divided by 36 will be 0.28. Okay. Now question 4th. If probability of C is 0.2, probability of A union B is 0.5, and probability of A union B union C is 0.6, what is the value of A union B intersection C? So first of all, we have to find out here A union B intersection C. So let us consider A union B as D. So it can be written as probability of D intersection C. And by addition rule we know that probability of A union B is probability of A plus probability of B minus probability of A intersection B, correct? So if we put this value here, we can get probability of A intersection B is equals to probability of A plus probability of B minus probability of A union B, right? So here if we look, here A, this is A and this is B. So probability of D intersection C can be written as probability of D plus probability of C minus probability of D union C, correct? So if we put the values of here, that is probability of D means probability of A union D, which is 0.5 plus probability of C is 0.2 minus probability of D union C is 0.6. So in total it would be 0.5, that is 0.1. Understood? Right? So if you look into the solution here, we have been given probability of C as 0.2, probability of A union B as 0.5, probability of A union B union C as 0.6. We need to find out the value of this, right? So let us consider A union B as a set D. So probability of D is 0.5. If we see here, this is probability of D, right? That is probability of D as 0.5. And this can be written as, let us group this thing together. So D union C will be 0.6, okay, and probability of D union C is 0.6. So we know that probability of D union C is this by addition rule. So intersection will be this one. So putting the values, we get 0.1. So this is our answer. Okay. Now question 4. We have the same situation, but we have different question. We have to find out the value of complement of probability of this, right? What is complement? If we have to find out the complement of A, right? So it will be equal to 1 minus probability of A, correct? We have to find out the complement of this, that is probability of A union B union C complement is equals to 1 minus probability of A union B union C, right? And what is the value of this? It is here, it is given. So it will be 1 minus 0.6, which will be equal to 0.5. Okay. So if you look into this, let E be the event. That is probability of E complement will be equal to this formula. So complement of A union B union C will be 1 minus A union B union C, which is 1 minus 0.6. The answer is 0.4. Okay. Now question 5. An urn contains 6 white, 4 red and 9 black balls. If 3 balls are drawn at random without replacement, then find the probability that one is of each color. That is, if we are drawing out 3 balls, one ball should be of white, second ball should be of red and the third ball should be of black. Okay. How many white balls are there? There are 6 white balls, there are 4 red balls and there are 9 black balls. In total we have 19 balls here. Correct? So what is the probability? First of all, we will choose one ball from these white balls. It will be 6C1, and we have to choose one ball from the red, which is 4C1. Similarly from the black, which is 9C1. Divided by the total probability will be, from 19 balls we have to choose 3 balls, right? So if we solve this, 6 into 4 into 9 divided by like putting the formula of combination, it will be 19 factorial divided by 3 factorial, right? So it will be 6 into 4 into 9 divided by 19 into 18 into 17. 3, like the denominator can be put here, which will be equal to 3 into 2. So if we solve this, we will get 0.22 as the answer. Let's look into the solution. Total number of cases is 19C3, because from 19 balls, from the total 19 balls, we have to select 3 balls, right? So 19C3 will be 969. Thus, P, that is probability of getting one ball of each color. That is, from these 6 white balls, we have to select one ball. From the 4 red balls, we have to select one ball. And from the 9 black balls, we have to select one ball. So in total would be 6C1, 4C1, 9C1 divided by the total number of cases will be 19C3. So if we solve this, we will get 0.22 as the answer. Fine. Now last question, given 5 numbers and 2 alphabets which are to be placed next to each other for making a security password in laptop. So in total we have how many places? That is 5 plus 2, which is 7 places we have to fill. Okay, and in which 5 are numbers and 2 are alphabets. So we have to find out the probability that there are exactly 2 numbers between the 2 alphabets. Like if these are the 7 places that we have to fill, 4, 5, 6, 7. So the question is, in between the 2 alphabets there should be 2 numbers. That is, these are alphabets, so in between them there should be 2 numbers. Okay, so how many cases this can be done? It can be like here. Okay, like in the this is the first case and this is the second case. In the first case, in the first digit the alphabet can come, and in the 4 digit the alphabet can come. Similar in the second case, in the second place we can have the alphabet in the second and fifth place. Okay, then in the third case, 4, 5, 6, 7, we can have in the third digit as an alphabet, and in between 2 numbers then we could have an alphabet. And we have fourth case, 1, 2, 3, 4, 5, 6, 7. Like in the fourth place we could have an alphabet, and then we could have in the last place. So how many cases are there? In total we have 4 cases, right? And these 2 digits can be arranged in 2 ways, right? So in total we would be having 4 into 2, which is 8 cases in total. And now total case will be, that is, in the first place, like the alphabets, the 2 alphabets can be the one alphabet can be in any of the 7 places, right? And the second alphabet can be in any of the 6 places, right? So there are 7 into 6, that is 42 ways. Correct. So probability will be the number of favorable cases, that is 8, divided by the total case will be 8 by 42.